Hi everyone, welcome back to Astronomy with Claire. So it's going to be a short one, this one, but super excited. So the telescope's outside, the new camera is all set up, Nina is all set up, and I have set all the focus up and everything like that. It's polar aligned, and I've just seen the first image from the new camera of Betelgeuse, and that's the main star of Orion, and it looks great. I'm very excited to see. I'm in my warm weather gear because I kept running outside and making adjustments and stuff. So my alter hat and my warm jacket. And so, okay, basically what you can see over here, so I have pre-aligned the telescope to point to a star called, I'm going to pronounce that wrong, Allentak, not entirely sure. I'm going to have all the astronomers going, oh my god. Basically, it is the left most star of the Orion's belt. It's quite bright, you can easily see it in the sky, but around that area is two great lovely things that I've imaged before but I'm dying to image with this camera, is the Flame Nebula and the Horsehead Nebula. Now basically the Flame Nebula is some gas that has been energized or excited essentially to glow by this star here, which produces this effect, and then this dust is between us and that gas, so it kind of gives it sort of like a flame effect. The Horsehead Nebula is called that because simply this bit here looks like a chess piece, the knight from a chessboard. So, and it's sort of a piece of gas and dust that's sticking up in between us and this red glowing, I think it's hydrogen background. So what I want to do is, with the new camera, just go for a single shot of that area to see what we get. Okay, so the telescope is tracking. As you can see, that is the previous image that I took of Betelgeuse, and it is a red supergiant. It's enormous, and it is in the final years of its life. At any moment that could go supernova. It wouldn't affect us, but it would look spectacular in the night sky when it does. It could go anytime supernova between now and another 100,000 years or so. In astronomy terms, that is 5 minutes time, but obviously to us then that could be waiting forever, but that is the brightest star that is in the top left hand corner of Orion. Now the telescope has moved down a little bit and is now pointing at this this bright blue star that is one of the three of the of Orion's belt. So what I'm going to do is I'm just going to take a random picture. So I'm going to start exposure now. So for 60 seconds. So for me, this is my Hubble Space Telescope going to the James Webb Telescope. So everybody's really excited about the James Webb Telescope. Super excited about that, about seeing what results it can do, because it's so much bigger, so much better than what Hubble can do looking in the infrared part of the spectrum. And I've only gone from an Altair 290C camera that I've been using in the past to this one, which is a 26C, which is so much better. So here we go. So we've got 10 seconds to seeing what we get from this super sensitive camera, which should produce quite a good image, and fingers crossed that we get something good. So here goes. So it's now preparing the image for us. It's going to be a lot bigger image because the chip for this camera covers a lot bigger area. But here we go. Let's see what it does. Fingers crossed it's something good, or I may end up just pointing at just complete darkness or nothing really at all. But let's see what happens. Hopefully it doesn't go horribly wrong. It may do. It may need some plate solving to be pointing in just the right place. But I plate solved to Betelgeuse, so as we know, we've plate solved on things before. So, oh my goodness. Wow. Look at that. That is one 60-second photograph. One. And we can see, look. Wow, look at that. There's the flame. This is live. This is in the sky right this second. These photons have hit the camera sensor. So we can see, oh my gosh, what can we see? Okay, so, oh my gosh. Right. So we can see, okay, so there's a little bit of dust on the telescope itself, so that can be, we can work that out in processing. Okay, so here is Alintac. So here we go. Alintac is there, and looking at, so there's the flame nebula. So we can see which way the camera is rotated compared to this picture. So we can see that that star there is probably that one. That one is probably that one. The belt is going to be going this way. So that's the left-hand star. That star there is this one here. We can see the nebulosity around that star. And we can see, we can see the Horsehead Nebula there, which is just the, against this area. And this is one 60-second photograph. Now, I can take much longer exposures with this, and I can take multiple exposures. And what that will do is, the more exposures you have, the better, in that you get better detail. It's called the signal to noise ratio, and the more images you get, the more the noise we can get rid of, and the better image it will produce at the end of the day. So for example, let's go for 120 seconds, so that's 2 minutes. Let's see what we can get for 2 minutes. I've not really explored how to set up the camera properly or everything like that. I've just basically plugged everything in and got focus and set it off, and just to see what happens. And yeah, very exciting. So what I'm planning to do is, after I've done this recording, is to just set it recording multiple images, saving them to the computer that's outside, and then bring those files in, and then stack them all up in the folder. And then tomorrow I can set the software to be stacking them, and so we end up with our final image, which I'll put onto the Instagram site and onto the Facebook page. So just waiting for, there's a little bit of high cloud out there. It's supposed to be fairly clear around about now. Orion is still rising in the east, so this is pointing mostly east from my back garden. But as you can see, it's like so much detail in there already, just from 60 seconds. So you can see this gas it's being energized, ionized by this star here, which causes it to glow. And then these tendrils of dark gas, as I say, are between us and that glowing gas, which luckily gives us this nice flame effect. So we're almost there, we're almost at the 2 minutes. So we're the software is calculating which colours to apply to which pixels, preparing the image now, and let's see what we get for 2 minutes. Remembering that was 60 seconds. See what we get for 2 minutes. Can't wait. See what we get. Okay, really excited. Okay, let's see what happens. I want tenterhooks. Wow, there you go. So, an even better image, and so there's more detail to it. As you can definitely see the horse head here, and this is just a raw image. It's just a raw. It's like when you take a photograph of anything, and you just go click. There you go. Before you tidy it up, maybe take it into Photoshop or something and sort it out and crop the edges and things like that. This is literally just that, and there's lots of noise. So you can see lots of noise is on the image, which will be taken out in processing, as will these two little blobs here. So this is dust that is somewhere in the image train, so from the far end of the telescope all the way down to the sensor. So there's probably dust that's on the actual glass itself, more than likely, and that can be taken out with processing. So yeah. Very excited. So I can very quick also just look at the camera itself. So this gives us a lot more detail about the camera than we were getting before. So we can see that each picture is 6,224 pixels wide by 4,168 deep. The cooler the chip, the less glow we will get on the chip itself, because obviously the longer you're keeping you're taking a photograph, the warmer that chip will get. So for long exposures, you want to keep the chip as cool as possible. So at the minute, I don't quite know. It might be just above 0. I think that's what it's saying here, just above 0. Oh yes, here we go. Chip temperature is 3.2 degrees C. Wow. Okay, so look at that. That's amazing. So what we could do. So the other thing that's quite close by is the Great Orion Nebula. So it's this one here. So we could just take a peek at that. So the Orion Nebula is a lot brighter than the Flame Nebula. The Orion Nebula is basically where stars are being born. So what I can do is go like that, and current object and slew. So the telescope is moving very slightly to this new position. Okay, so it's now settled. And now that I've done some plate solving already, so fingers crossed it should be around about in the right place. But what we can do is, so let's just do 2 minutes on there. Let's just take a snap of that portion of the sky. So that what we're taking a photograph of now is the Orion Nebula. It is a Messier object M42. it is where lots of gas and dust is condensing to form new stars. And those new stars, when they ignite, when they basically start glowing, like our own sun during the day, is you can see it's glowing. It causes the gas and the dust that it was born from to glow as well. So we can see that here. That's what all this is happening. So all of these stars here are in this this birthplace, essentially, this stellar nursery. So let's just go back to, click on the right thing, and see what happens, what we get. The Orion Nebula is a popular target in winter. As the Flame Nebula is as well, but the Orion Nebula is quite a popular target for astronomers at this time of the year. So we've 84 seconds, we're at 115 seconds, almost there, and okay, done. So now it's processing the image, it's working out all the little pixels, what colour they should be, preparing the image for star detection. Not entirely sure what that means, but doing something exciting. And I just wait to see what happens. Again, Nintendo hooks, excited to see what happens. Come on, let's see what you're gonna do. Oh, wow. Wow. Oh my goodness. I don't know why I'm blushing, but it's like, wow. Look at that. One 2-minute picture. That's unbelievable. Look at it. That was taken right now, right this second. That was taken. That is in the sky right now. So we can see all of the, oh my goodness, all this beautiful pink glowing hydrogen from these stars that are in here that are just been born in stellar terms millions of years ago, but they're very new, very hot stars that are causing. Look at that! Wow! Look at all this dust here, and this glowing gas. Just up here, there's also the Running Man Nebula. So this looks like a man or woman, indeterminately, with their head there and their arms outstretched and their legs, they're running along. And look at that, that is amazing. Oh my goodness. Right, well, super happy with that. Right, I'm gonna do some more images of this, grab as many as I can, and that's it for now. Okay, well, this is short and sweet-ish for one of my videos anyway. If you like what you see and you want to see more of what's going on, I certainly do. So just hit like, subscribe. It will pop up when you see more. I do more videos, especially now I've got this camera. And I will see you again soon. Try for now. Bye bye. Wow.